This is question 42 of chapter 9, and the question goes, the vector position of a 3.5 gram particle moving in the xy plane varies in time according to a function. At the same time, a vector position of a 5.5 gram particle varies at a different function, where t is in seconds and r is in centimeters. At t equals 2.5 seconds, determine A, the vector position of the center of mass, B, the linear momentum of the system, C, the velocity of the center of mass, D, the acceleration of the center of mass, and E, the net force exerted on the two-particle system. So, okay. Question 42. Well, before we actually start A, let's first find the position vector of the center of mass. We know that R1 is equal to 3I plus 3J T, my God, pencil, plus 2J T squared. And R2 is equal to 3I minus 2I T squared minus 6J T. For each of this, R1 has mass of 3.5 grams, R2 has 5.5 gram particle. I'm actually going to rewrite this so the I's and J's are grouped together in each. So R1 then would equal 3I plus 3T plus 2T squared J, and R2 would equal 3 minus 2T squared I minus 6T J. Now to find the position vector of the center of mass, the formula is R1 M1 plus R2 M2 over M1 plus M2. So when you multiply this out according to the formula, this is what you get. So from here, you simplify a bit, and that would get you negative 11t squared plus 10.5t plus 16.5 over 9i plus 7t squared minus 22.5t over 9j. Now the question asks for the vector position of the center of mass, which is this, but at time equals to 2.5 seconds. So instead of t, we're going to substitute it with 2.5 seconds, and that should give you approximately negative 2.89i minus 1.39j, and the unit is centimeters. Okay, part B. Part B asks for the linear momentum. Momentum is equal to mass times velocity. You know the mass because it's the mass of the system and there's two particles in the system, which means mass is equal to 9 grams. But velocity, it's not as apparently stated, but velocity is equal to the derivative of the position relative to time. And another way to write x is dr dt, which is what the question gives us. And you found r in terms of t here. So now actually that's that guy as well. This is the more simplified term. So we're going to derive this guy and end up with negative 22t plus 10.5 over 9i plus 14t minus 22.5 over 9j. Again, you plug in 2.5 seconds to get the velocity at 2.5 seconds, And that should give you approximately negative 4.94 plus 1.39 J in centimeters per second. Now to actually use the momentum formula, we know this, and we know this. So you multiply the two together to get negative 44.46 I plus 12.51 J, and the units this time is grams times centimeters per second. Like so. Ooh, that's part B. Part C asks for the velocity of the center of mass. Well, you found that right here while you were solving for B. So this guy is answer to part C. Okay, moving on to part D. Part D asks for the acceleration of the center of mass. We know that acceleration is the derivative of velocity over time. And you found velocity in part C, except in terms of t right here. So now if you're going to differentiate the velocity in terms of t, you would end up with negative 22 over 9I plus 14 over 9J. This simplified is equal to approximate negative 2.44I plus 1.56J, and the units for acceleration is centimeters per second squared. Okay, and the last part, E, asks for the net force exerted on the two-particle system. Well, we know force is equal to mass times acceleration, and same as part B, mass is going to equal 9 grams. Acceleration we found right here. So we multiply the two. And that should give you approximately 21.96 I plus 14.04 J in centimeter grams per second squared. From here, if you want to convert to newtons, you know that newtons unit is technically kilograms meters per second squared. So you're off by quite a bit actually. Therefore, newtons might not be the method you want to take. Instead, there is micronewtons, which then would not be equal to this. It would actually be something like this. And that would actually be slightly more appropriate in this case, where all you would have to do to here then is multiply it by a 10, which would give you 220I plus 140J micronewtons. And that's it.